In this video, we are already going to talk about heat capacity and specific heat capacity. Okay, so previously in the previous video, I stopped here. How much energy do I need to increase 1 degree Celsius? Okay, so imagine I have this is liquid X and I have liquid Y. Okay, under the same situation, they are facing the same heat source, which is the sun. Okay, if I put them under the sun, okay, expose them, everything is the same, surface area is the same. Okay, there's no other factors that are different. Okay, now the question really is how much thermal energy do I need to increase 1 degree Celsius? Okay, and that's the entire idea of heat capacity, which is also similar to what I asked in the previous video before we started this chapter. Okay, regarding the ice and water. Okay, which one will increase more when exposed to the same heat source? Which one will have a greater increase in temperature? Sorry, okay, not increase more. Okay, so that's the idea of heat capacity. Okay, and the definition really is over here. Okay, so take some time to copy this down. Okay, I'm going to copy this into the notes as well. Can I do that? Okay, I think I can do it here. Okay, you may want to pause the video to copy this. Okay, I'm just going to transfer it. Okay, so you should have, oh no. Okay, so you should have this. The heat capacity of an object is the energy needed to raise its temperature by 1 Kelvin. Okay, 1 Kelvin is okay. 1 Kelvin is also the same as 1 degree Celsius. Okay, now the formula for heat capacity is this. Okay, C equals to Q over change in theta. Okay, change in theta would be the change in temperature. Q would be the thermal energy required. And of course, this C, which is capital C, okay, is the heat capacity. Okay, sorry, give me a minute. Okay, I'm gonna pause the video for a while. Okay, sorry, and I'm back. Okay, so this is the formula. Okay, but it's usually written with the subject as Q. So if we are to change it, Q equals to C times the change in theta. Okay, it looks nicer. There's no fraction here. Okay, so this is the formula that you will be using. Okay, now the next thing that you will be learning is called specific heat capacity. Okay, so I'll define that. Okay, and I'll tell you the difference. Okay, but before I do that, okay, really please understand the meaning behind Q, the meaning behind C, and the meaning behind change in theta. Okay, it must be a change in temperature. Okay, if we can't determine the heat capacity of an object if we supply thermal energy to it and there's no change in temperature. Okay, because really the question is still how much thermal energy do I need in order to increase 1 degree Celsius, right? Remember this. Okay, just remember the ice and water example. Okay, now what is the SI unit then for heat capacity? Okay, you will follow the formula. So the formula for C is Q over change in theta, right? And Q is thermal energy. Thermal energy has the SI unit of joules. Okay, change in theta has the SI unit of Kelvin. Okay, so it will be joules per Kelvin or joules Kelvin minus 1. Okay, so you may also want to write joules per degree Celsius. Okay, I personally prefer this. Okay, so it's really up to you. Okay, it's the SI unit follows the formula. Okay, so if you remember the formula, there shouldn't be a problem with your understanding of SI unit. Okay, so this is the idea of heat capacity. Now, what is specific heat capacity? Then what's the difference, right? Okay, now let me show you the definition first. Okay, sorry, over here it should be as the amount of energy needed to raise the temperature, right? Okay, so over here this will be the definition. Okay, let me do the same thing. I'm gonna copy paste here. Okay, and then okay, so this is the idea of the specific capacity. Okay, the difference is over here, the um here 1 kg of material. Okay, if you were to compare the two definition, you have 1 kg of material over here, but you do not have it here. Okay, there's nothing talking about 1 kg of material. Okay, so specific capacity is when you look at just 1 kg of an object. Okay, so usually specific capacity is a better measure because um, if you give people heat capacity, right, the next question um, that arises is what is the mass, etc. Okay, when you give specific capacity, we know for sure that the mass that you are using is 1 kg ice or 1 kg of water, etc. Okay, so the formula is somewhat similar. Okay, it will be written as Q equals to mc times change in theta. Okay, note that this C, right, is small letter c. Okay, it's not a big letter C, and the rest is the change in theta is still the change in temperature. Okay, Q is the thermal energy, no change. Okay, and M, which is a new introduced quantity, is mass. Okay, because if we know the specific capacity of 1 kg of water, okay, I want to find the thermal energy required to raise the water by 10 degrees Celsius. Mass will be 4 degree. Okay, because I mean 4 kg, because we are dealing with 4 kg of water right now. Okay, we are no longer dealing with one. Okay, so later on we'll be doing questions. Okay, then you'll see for yourself what's the difference between heat capacity and specific capacity. So don't worry about it now. Okay, I think with examples this will be even more visible to you. Okay, same thing, we are going to make C the subject. Okay, to really define the idea of specific capacity, and C will be equals to Q over M times change in theta. Okay, still the same thing, I prefer this formula because it's linear. Okay, because there's no fraction to it. Okay, but anyway, the SI unit for specific capacity will then be joules per kg per Kelvin. Okay, or you want to write it as joules, sorry, or it can be written as joules Kelvin minus 1 kg minus 1. Okay, it's really up to you. And the same thing, Kelvin, you can write it as degrees Celsius too, I guess. Okay, but this is what I prefer. Same thing. Okay, always write my preferred one first, right? Okay, so this is the idea of heat capacity, internal energy, and specific capacity. Okay, please raise your questions in class if you have any. Okay, and pause the video appropriately if you need to copy anything. Okay, the next one would be that in the next video, right, I'll be doing an experiment. Okay, I'll be putting thermometer into alcohol and water, and I'll supply heat to it. Okay, and we'll see which one will have a greater increase in temperature. Okay, so yeah, do predict. Okay, say which will increase more. Okay, you may also want to say why do you think so. Okay, and you may even Google for your own reference. Okay, so in the next video I'll show this. Okay, no worries about this. Okay, in the in the next lesson, right, I'll also be doing this. Okay, so do try the questions here on page 4. Okay, try the questions, and yeah, especially this. Okay, try to remember how to use the PRO method. Okay, this will using the PRO will definitely give you the 3 marks. Okay, so I'll stop the video here. Do try page 4 before coming to class. Alright, thank you.